Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to discuss assessment of drought characteristics. So what we learned last time, we understood various drought indices like SPI, Standardized Precipitation Index, SPEI, Standardized Precipitation Evapotranspiration Index, SRI, Standardized Runoff Index, and other indices, and what are their data requirements. We also analyze the application of various drought indices, in under which case, for agriculture drought you should use which indices. For meteorological drought, SPI, SPEI are used. For a hydrological drought, SRI or SBI are used. Then we presented a comparative assessment of various drought indices, that what are their limitations, what are their advantages, and so on. The learning objectives for today's lecture is we will understand the fundamental concepts of drought characteristics and their hydrological significance. We'll identify key drought parameters such as initiation, termination, duration, intensity, and severity. We'll also learn methods to quantify drought characteristics and their transition states. So beginning with the numerical definition of droughts. So drought is where it is associated with kind of deficit or insufficient or inadequate or stress or shortage. So that these kind of words are very frequently associated with drought. So when water and water availability is constrained, then linguistically you define these words to denote droughts. But for example, let us say if we consider precipitation, so any period, if you consider whether it is days, weeks, months or years, it can be classified into two broader categories, whether it is rainy and non-rainy. If you are considering runoff, you can classify it as dry or wet, and similarly for the soil moisture. So basically it's a binary classification where you can classify into two states, whether it is rainy or non-rainy, or whether it is dry or wet. Now if a time series record is available with you, then what we can do, we can take an arithmetic average which can serve as a threshold, and it can be used to identify various drought categories. For example, if this is the average, which is called the mean state of any variable, so how much the values are deviating from the mean, that we can identify and express that in a more numerical manner. So for example, when we analyze drought, so for any hydrological time series, we consider a truncation level or a threshold. So that is what separates the rest of the series with the drought or a wet spell. So usually when you're trying to analyze drought, you either take monthly, or sometimes you may take fortnightly or seasonal scales, but usually monthly scales are more preferred. But we don't like floods. It is a very short term phenomena, so we go into more kind of hourly or sub-hourly data, but that we cannot do with drought. So using daily values to characterize drought would result in specific problems. First is dependency among droughts, and second is presence of minor droughts. So if there is a prolonged dry period, so you can see here there is a prolonged dry period. So what can be when your flow falls below a certain threshold for a short period of time. So in that the drought events can be divided into several number of minor droughts. So that is why what happens, that you do not get a proper picture of the drought. Second, these are mutually dependent, so they are not as an independent event. So one event is already dependent on another, so that dependency comes into picture, and where their independency is not well established. So we avoid using daily time step to denote droughts. However, there is an advanced terminology which are called flash droughts. So they use a certain time window which can be pentads, that is 5 days accumulation periods, or octads, which are 8 days accumulation period. So they are used to define flash drought, but not on a daily scale. So let us first identify that how we can define states. So any value where your xi, your now x naught is your truncation level that is set. It can be either 0, it can be either plus or minus 0.5. So one truncation level is decided. Based on that you can classify the states. So if your value is greater than the truncation level, you move upwards on the y-axis, so that is a wet state. And what is the surplus amount? Surplus amount is your xi minus xo, which is greater than 0. Now if your value of xi is less than the truncation level x naught, that means you are going on the negative side, and that becomes your deficit or a dry state. And the deficit amount, again your xi minus xo, that would be your less than 0. So your deficit amount would be less than 0. So this is a wet state, you can see that it is positive, and this is the dry state where you can see that it is negative. So that is below a truncation level. So similarly you can see here, this is a wet state, this is a dry state, and so on. You can find several wet and dry states. Now it is not necessary that 0 can be your truncation level. Some studies consider plus or minus 0.5 as truncation level. Then your question will be, then what is that which will be there in 0.5 to minus 0.5? What will be there in this range? So that is called normal, where that is attributed to normal fluctuations of your rainfall values. So within that fluctuation is allowed. Some studies consider plus or minus 0.8 as well. So that is a subjective criteria used for by different researchers. Now let us define a wet spell. So a wet spell is defined as the delimitation of consecutive uninterrupted wet spells by at least one wet state. So when you want to define a wet spell, there should be at least one wet state. That means one case where your xi is greater than x naught, that is minimum one value. So to identify a wet spell, what is the duration of wet spell? Let us say we identify the beginning and ending of a wet spell where it is a dry state. So you can see that in this particular case, so this is the ending of a dry state. So before that there is a dry state, and after this point also there is a dry state. So if this point is your I and this point is your j, so your wet spell duration is j minus I. That is how you can define the duration of wet spell. Now dry spell, again it is an uninterrupted sequence of the dry states which are delimited by two ends with at least one wet state. So let us understand. So here this is a wet state, so you can see just before this point here, this is a wet state, so this is my k, and just before this point, just after this point, there is another wet state which is L. So your L minus k will be your dry spell duration. So this is how you can formulate what is your dry spell duration, and of all dry spells you take the maximum value, that will give you the maximum dry spell duration. Now to go more detail into the drought characteristics, Yevgevich proposed a theory of runs to define your drought characteristics. So what does this theory of run imply? So you can see that this is a sample drought series, so we are considering a SPI accumulated over 3 months to just represent it. All the blue values are excess, which are positive, and all the red values are negative, which are deficits. So I'm using the word very clearly, excess and deficit. I'm not defining a deficit as drought. Why? Because to define a drought you need a truncation level. If I take 0 as a truncation level, any values less than 0 will be drought. If I take minus 1 as a truncation level, all the red values below minus 1 will be drought. So that is why I should be very precise when I define drought. So run is defined as a portion of time series of the drought parameter xt, so there's xt, that is SPI, in which all values are either below or above the selected truncation level x naught. Accordingly, either it is called a negative run or a positive run. So for simplicity, let us consider threshold as 0. So all values which are above, so you can see that from this point till this point, you can see it is a positive run because the values are continuously above the threshold. Now from this point to this point the values are continuously below the threshold, we can call it as a negative run. So you have to find what are the runs. So when the run is broken, so usually again there are several criterias. Some say that it can be this way. For example, if your values are 1, 2, 3, 4 are positive, 1 is negative, then again there are positive. So this one negative they do not consider as a break in the run, because that can be due to some abrupt fluctuation. So they say that if there are 3 consecutive values which are opposite to the existing state, then you can say the run is broken. Otherwise this one value is a part of the run. So these kind of guidelines are also provided. Now let us understand when a drought initiates and when a drought terminates. So the initiation of drought is defining a period where water shortage just begins, and the termination of drought where water shortage become very small, so that the drought conditions no longer persist. So let us understand. So in this figure we have taken a threshold x naught. So based on the threshold, this is a positive run, this is a negative run. So all these values which are below the threshold, which are in negative run, will be the drought. So we have identified there are 3 drought events. This is number 1, this is number 2, and this is number 3. So there are 3 drought events. Now let us understand, your Ti is your initiation time, so drought begins at this point, and Te is your termination, so drought begins ends at this. So let us say if the value of Ti, that is a time scale, we assume it to be a monthly time scale. So Ti is equal to, we will start here, this is 0, 1, 2, 3, 4. So Ti is equal to 4, and your Te, so that is 5, 6, 7, 8, 9. Te is equal to 9. So drought duration, that is equal to 9 minus 4, that is 5 months. That will be your drought duration. You can verify this is 1, 2, 3, 4, 5 months. So here you can see 1, 2, 3 months. So that is how you can identify the drought duration. So drought duration is defined as a number of consecutive intervals or month where your SPI value remains below a threshold. So minus 0.8 is the most widely used threshold. That is why we have indicated here that so for rest of our studies we'll be considering minus 0.8 as a threshold for drought. Now since drought event is defined at the aggregation of monthly time scale, the minimum duration of drought has to be 1 month. There cannot be a drought which is lesser than 1 month. So in other words, the initiation and termination time should be minimum 1 month. So your Di is Ti minus Te for all SPI less than 0.8. Now, so this is your drought duration, you can get it. So we already calculated it. So for this case the drought duration is 5 months. For this case 1, 2, 3, 4, 5, 6 months, and for this case it is 3 months. That is the drought duration. Now coming to the drought severity indicates the cumulative values of SPI. Now this is just for SPI. If you have any other indice like SPEI or SRI, the theory of runs remain the same, and this drought characteristic has to be interpreted in the same manner. So cumulative values of SPI within the drought duration, that you have to count. So for convenience, what we can take the values to be positive. So for example, here what are your SPI values? Let us say here your SPI value is minus 2, this is minus 0.2, and the third one is minus 0.6. So you just sum it up. So what is that? Is minus 2 minus 0.2, so that becomes minus 2.8. so that is a cumulative value. So your severity is equal to summation of 1 to D, so that is 1 to the total drought duration, so minus of minus 2.8, so that becomes plus 2.8. so for simplicity we are just denoting it positive, so that is the severity. Now drought intensity, that is the average value of SPI within the drought duration, so it is measured as severity divided by the duration. So your severity, so how you calculate intensity? Your severity, let us calculate. Your severity is 2.8 and your drought duration is 5, so 2.8 by 5, So this becomes 28 by 5 and sorry into 10, so this is 0.56. so that is your intensity. So your intensity becomes 0.56. so let us now understand that how would we calculate it. So you have three different drought events which are provided here. Now you have to answer three questions. Number one, which drought has the longest duration? So you have drought, let us estimate the drought duration for here. So drought duration is 5, drought duration is 1, 2, 3, 4, 5, 6 and drought duration is 3. So which drought has the longest duration? So your answer should be, I think, drought 2, that is the event number 2. Second is, which drought has the highest severity? Now you just sum it up. Now since you do not have the values, but approximately you can see that. So as per my logic, I think drought 1, you know, the values appear to be more larger as compared to others, so maybe drought 1 should have higher severity. And last one, which drought has the highest intensity? So intensity is severity divided by the duration, so I think the duration is less here, this is the highest value, so maybe drought 3 should be of higher intensity. Let us check our answers. So what our answers? Yes, drought 1 is with the highest severity, drought 3 is the highest intensity and drought 2 is the highest duration. So our answers match. If you have exact values, you can get more accurate results. So here we just took an idea that how it could propagate. So this is how the theory of runs help us in, you know, defining the drought characteristics. So in a similar way, just to summarize, you can locate the time of start of the drought, time of end of the drought, so between that you get the duration and then you can compute other characteristics. So just summarizing, so number of drought events, that is you are counting the total count of drought index, it can be any index where the value is less than 0.8, so that is a drought. Then maximum drought duration is maximum of all drought events which are less than 0.8, then severity, and then you get the intensity. Now let us understand the transition, how wet to dry transitions are defined. So let us say we use any index SPI, it can be of any time scale, so we denote SPI n, where n is a time scale. So first you segregate that, let us say your truncation level is 0.8 plus or minus 0.8. So SPI values less than 0.8 are dry, greater than 0.8 are wet. So you have identified the wet and dry states. Now let us understand dry to wet transition. So how that transition happens? First dry month followed by a first wet month. So when there is a dry month, let us understand on the time scale. So this is a dry month and this is the wet month. So how the transition take place from the first dry month to the first wet month? So that is followed. So for example, you know, there are so many dry months and then suddenly a wet month comes. So we should understand that at this point there is a transition from wet to dry which is happening, and in the reverse way, if there are several wet months and then there is a dry month, then the transition from wet to dry is happening. So you should identify all these transition cases, provided your value is less than minus 0.8. If the value is, let us say, minus 0.3, minus 0.2, that we do not quantify as a dry state, because your dry state is defined with respect to a threshold. So that threshold of minus 0.8 should be breached, then only you can go into wet to dry transition and the reverse way. Now you have to count how many dry to wet and wet to dry events occurred over a period. So how many transitions were there from the dry to wet state and how many were there from the wet to dry state, that you count over the entire study period. Now once you have that, you calculate the wet to dry ratio. So this is the wet to dry ratio. So that is natural log of NW, that is number of wet months, to ND, number of dry months. So this ratio will give you that how your extremes are behaving. So if the wet to dry ratio is very high, so So that means there is a very alternating state of change in the precipitation or other regimes happening in your region. Average transition time. So let us identify average transition time. For that, we start with identifying wet and dry months. So what are the wet and dry months for a given SPI n? Then you combine continuous wet or dry months into a single event, like you mark only the first and last of these events. So what is the beginning of the wet event, what is the ending of the wet event, and so that you can classify this. Now there are four types of changes available. Either it can be a transition from wet to dry, dry to wet, wet to wet, and dry to dry. So let us understand on a timeline. So these are all months. So coming to the first value, so this is what, so this is a dry and this is wet. So this is a dry to wet transition. So you have dry to wet transition. So let us put a frequency 1. Next is this point and this point. So it is a wet to wet transition. So again the frequency is 1. Then between these two, again a wet to wet, frequency is 2. Then here it is a wet to dry transition. So it is wet to dry transition. So the frequency is 1. Then you have dry to dry transition. The frequency is 1. Then again a dry to dry transition, frequency is 2. Now you have dry to wet transition, so again frequency is 2. Wet to dry transition, 1 more. Then dry to dry, 1 more. Dry to dry, 1 more, and so on. You can go on counting the frequencies and get all kinds of transition that are happening over the time. Now next you find the interval, measure months before months between two consecutive events to get the transition time. So in this way we compute the months between two such transitions for these 4 states, and then we take mean of all transition times for each grid point, and then we can plot them spatially. So your transitions will give you an idea about the shift between the wet and dry phases. So based on some results we have taken from this study by Singh et al. So you can see how the drought characteristics vary in a space and time across several semi-arid catchments in India. So the first one is number of drought events in months. So this is on an annual scale. Then note the severity, then maximum number of drought duration and intensity. So you can see that the higher value is represented here. So you can see all blues are on the higher side. So this you can see that there is a higher number of droughts in a year for these particular river basins. Same here you can see that droughts have been more severe across these river basins in this particular years. The droughts have been more intense for these particular river basins and for a given year. So here you can visualize on an annual scale what are the severity, intensity and duration of the droughts, and also for different catchments, so you can get an idea how simultaneously droughts are being propagated. There are other classifications also being used. So this is from the drought monitor we have taken up. So they have taken a truncation of 0.5, so that is any values above or below, that is 0.49, they are considering normal conditions. So as I told that different researchers have used different thresholds. So minus 0.5 to minus 0.79 they consider abnormally dry. So moderate drought between minus 0.8 to minus 1.29, and anything less than minus 2, that is a exceptional drought. So based on that, D0, D1, D2, D3, D4 categories are being crowned, and their impacts are shown. That if it is an abnormally dry, there will be some dryness in the plant and plant growth can be affected. Moderate, then there can be damage to the crops or reservoirs will experience water shortages. Severe drought, water shortages will be more common, there will be restriction imposed and pasture loss will be observed. Extreme drought, there will be crop loss and widespread water shortages. And exceptional drought, there will be shortage of water in reservoirs and streams causing emergencies and other effects. So there is a drought monitor in India developed by IIT Gandhinagar. So you can see this drought monitor. So all these categories D0, D1, D2, D3, 4 are marked. So you can see the spatial variability. You can select a particular state, district, river basin boundary to get an idea of the drought. And then there are different options available. You can get drought time series, you can get the area under drought, you can get the stream flow monitor, drought types, etc., which is available, and then how much percentage of area is affected in drought. So their progression also can be noticed. So here is an example of SPI and SPEI. So if you look at this map, you will be able to interpret that these higher values of SPI greater than 2 indicates wetter spells. So you can see these regions in particular experienced more wetter spells when for the corresponding duration, and on the other side these regions in the north experience more deficits. Again you can visualize it for different indices like SPEI and other indices which are provided here. Now this you can see standardized runoff index. Same visualization can be noted where different conditions are being monitored, which regions are prone to more excess and more deficit. The India Drought Monitor also provides drought early warning system, where it predicts that which regions are likely to face droughts in near future if the conditions persist over a longer period of time. So what are the key takeaway from this lecture? We understood that the initial and termination of droughts are very important to identify the beginning and ending of a drought event, which is defined by the value of an index which falls below the truncation level. Drought duration is defined as a continuous months where the drought index is below the given threshold. Drought intensity is the average value of drought index using during a drought, and the drought characteristics help unearth various intrinsic features of the drought events in a region. So here's an activity suggestion for you. Identify a drought event using let us say SPI time series. You estimate the number of drought events, maximum drought duration, drought severity, drought intensity for all such events. So just to begin with, maybe you can have 5 years or 10 years of data, and you can derive the monthly series, and using the monthly series you can derive SPI either by parametric or non-parametric approach, and then go away with this calculations. So these are some additional references for you, and thank you for your attention. We'll meet in the next lecture to summarize drought estimation and assessment.